Hey, have you ever wondered why water behaves the way it does? Water exhibits a variety of special properties that contribute to its significance as a resource to us as humans. Let's dive in. The water molecule owes many of its unique qualities to its shape. According to the valence shell electron pair repulsion theory of molecular geometry, H2O is a bent molecule. This is because its central atom, oxygen, is sharing 4 out of 8 total valence electrons present through bonding with 2 hydrogen atoms that want to repel each other, while the remaining 4 valence electrons make up 2 unshared electron pairs bonded to oxygen. Molecules can form a multitude of different shapes based on a higher or lower number of electron domains around a central atom, and the number of total valence shell electrons in the molecule. Molecules that contain 4 electron domains around a central atom tend to have bond angles around 109 degrees, but 2 of water's electron domains are unshared pairs, which push the hydrogen atoms closer to yield a bond angle of 104.5 degrees, and to give H2O an asymmetrical molecular structure. Understanding the 2 types of polarity, the intermolecular forces at work here, is essential in comprehending the significance of molecular geometry as well. Bond polarity is caused by differences in electronegativity between atoms, and molecular polarity is caused by symmetry in the molecular shape or the presence of unshared electrons. The 3 forces of attraction in covalent compounds, also called van der Waals forces, are London dispersion forces, dipole-dipole interactions, and hydrogen bonding. These strong hydrogen bonds, only present in polar molecules, are created by hydrogen forming a bond with either oxygen, nitrogen, or fluorine. The bent structure of H2O exhibits both bond and molecular polarity. Properties like cohesion, when molecules are attracted to their same type of molecules, adhesion, when molecules are attracted to different types of molecules other than themselves, and surface tension, a cohesive behavior where a liquid's surface is able to withstand stressors or tension, all result from hydrogen bonding in and between water molecules. Water's polarity also allows it to be an incredibly effective solvent, so much so that it's referred to as the universal solvent. The general chemistry rule, like dissolves like, best explains this phenomenon. The more polar the solute, the more dissociation in solution will take place from a reaction with the polar solvent. This is why ionic compounds, which are 100% polar, like sodium chloride or calcium carbonate, easily dissolve in water. We can use this knowledge of molecular behavior to explain other substances' interactions with water. For example, oil doesn't dissolve in water, it remains separated. On a molecular level, oil is a non-polar substance, unlike water, a polar substance. Water is also unique from other substances in that it is more dense in its liquid state than in its solid state as ice. Water molecules, when frozen, expand into a rigid hexagonal structure, which takes up more volume. Now that we've done some swimming for answers, anytime you see water, you can look at it with a deeper understanding of how its atoms are behaving in your everyday life.